Welcome to our second lecture on the Lightning Network. We're going to talk about how to get started with the Lightning Network. This is part of the Understanding Crypto series. Our agenda for this lecture is we're going to dive into Lightning nodes. We'll talk about Lightning wallets. We'll talk about how to set up a Lightning wallet and how to make a transaction on the Lightning Network using Bitcoin. So we're going to begin where most people start when they encounter the Lightning Network for the first time, choosing software to participate in the Lightning Network. We're going to examine choices of several users who represent common use cases for the Lightning Network and learn by example. And in this particular case, we're going to take a look at the two typical cryptographic examples whenever you do a cryptography example, which is A and B communicating. And A and B are short for Alice and Bob. Now, in our Bitcoin lectures, we talked about Alice being a Bitcoin user who bought a cup of coffee from Bob's Cafe using a Bitcoin transaction. And in the Bitcoin lectures, that was way back in 2013 when Bitcoin was relatively inexpensive. Well, nowadays, of course, it's been a number of years since then. And so Alice at this point has used Bitcoin quite a bit, presumably going to Bob's Cafe and other places and using Bitcoin. And if you want to learn more about Bitcoin transactions, again, check out some of the Bitcoin lectures in the Understanding Bitcoin series. So let's suppose that Alice has recently learned that Bob's Cafe is now going to accept Lightning payments. So Alice is eager to learn about and experiment with the Lightning Network. She wants to be one of Bob's first Lightning Network customers. To do this, she needs a Lightning wallet that will meet her needs. Now, Alice does not want to entrust custody of her Bitcoin to third parties. She has learned enough about cryptocurrency to know how to use a wallet. She also wants a mobile wallet so that she can use it for small payments on the go. So she chooses to use the Clear wallet, a public non-custodial mobile Lightning wallet. Now, there's a lot of different wallets out there, and these are constantly changing. I'm not making any recommendations as to which wallet to use. This is just an example wallet for purposes of this lecture. So let's learn about how and why she's made these choices. So a Lightning node is how you're going to access the Lightning network. The Lightning network is accessed through software applications that can speak the Lightning Network protocol. And so any software application that wants to interact with the Lightning Network is typically referred to as a Lightning Network node. Now, generally, there are three characteristics that Lightning Network nodes have. The first is that the Lightning Network node is a wallet, so it can send and receive payments over the Lightning Network as well as on the Bitcoin network. Second, the nodes must be able to communicate on a peer-to-peer basis with other Lightning Network nodes creating the network. And third, the Lightning nodes also need access to the Bitcoin blockchain, or if they're using an alternative blockchain, they need access to that alternative blockchain to secure the funds used for payments. Users have the highest degree of control by running their own Bitcoin node and their own Lightning node. However, Lightning nodes can also use a lightweight Bitcoin client, commonly referred to as a simplified payment verification client, to interact with a Bitcoin blockchain and not run a full Bitcoin node if you don't want to. Similar to blockchain explorers for Bitcoin, we also have Lightning explorers. Network explorers are useful tools to show the statistics of nodes, channels, and network capacity, all of which we're going to get into and explain later in greater detail. Here's some example Lightning Network explorers, and there's a lot more. Now, when using a Lightning Explorer, just like when using a blockchain explorer, privacy can be a concern. If users are careless, the website can track their IP addresses and collect their behavior records. For example, the nodes users are interested in. And it should be noted there is no global consensus of the current Lightning graph or the current state of any existing channel policy, and users should not rely on Lightning Explorers to retrieve the most current information. Furthermore, as users open, close, and update channels, the graph will change, and individual Lightning Explorers may not be up to date. Use Lightning Explorers to visualize the network or gather information, but not as an authoritative source of what is happening on the Lightning Network. To have an authoritative view of the Lightning Network, you should run your own Lightning node and build your own channel graph and collect statistics, which you can view for web-based interface. Now, why did I say that privacy can be a concern? Well, it's similar for the reasons why if you're using a Lightning Explorer and you enter in search terms, well, the search engine will store those search terms. So, for example, and then they can use those search terms, they can associate with your cookies, and they may be able to figure out what you're interested in. And if you're constantly looking up your own accounts, then they might be able to guess that those are in fact your accounts. All right, so let's move on. So what are some of the common components of a Lightning wallet? So the term Lightning wallet is somewhat ambiguous because it can describe a broad variety of components combined with user interfaces. The most common components of Lightning wallet software include a key store that holds secrets, such as private keys. This is typically what you use with a Bitcoin wallet. A Lightning node that communicates on a peer-to-peer network, as we talked about on previous slides. A Bitcoin node that stores blockchain data and communicates with other Bitcoin nodes. A database or map of nodes and channels that are announced in the Lightning network. A channel manager that can open and close Lightning channels. And a close-up system that can find a path of connected channels from the payment source to the payment destination. A Lightning wallet might contain all those functions, act as a full wallet with no reliance on any third-party service, or one or more of those components may rely partially or entirely on third-party services that mediate those functions. And currently, the Lightning Network itself is going through a lot of growth and evolution, and we'll expect to see more evolution and growth on the capabilities of wallets. Um, a key distinction is whether the key store function is internal or outsourced. In blockchains, controls of the keys determines custody of funds. You may have heard the phrase "your keys, your coins," not your keys, not your coins. So any wallet that outsources management of keys is called a custodial wallet because a third party is acting as custodian and has control of the user's funds, not the user. A non-custodial or self-custody wallet, by comparison, is one where the key store is part of the wallet and keys are controlled directly by the user. The term non-custodial wallet just implies that the key store is local and under the user's control. However, one or more of the other wallet components may or may not be outsourced and rely on trusted third parties. Blockchains, especially open blockchains like Bitcoin, attempt to minimize or eliminate trust in third parties and empower the users. This is often called a trustless model, or although trust minimized may be a better term. In such systems, the user trusts the software protocol, not the third parties. Therefore, the issue of control over keys is a principal consideration when choosing a Lightning wallet. Every other component of a Lightning wallet brings similar considerations of trust. If all the components are under the control of the user, then the amount of trust in third parties is minimized, bringing maximum power to the user. Of course, this brings a direct trade-off because with the power comes the corresponding responsibility to manage complex software. Every user should consider their own technical skills before deciding what type of Lightning wallet to use. Those with strong technical skills should use a Lightning wallet that puts all the components under the control of the user. Those with fewer technical skills, both a desire to control their funds, should choose a non-custodial Lightning wallet. Often the trust in these cases relates to privacy. If users decide to outsource some functionality to a third party, they usually give up some privacy as a third party will learn some information about them. Finally, those seeking simplicity and convenience, even at the expense of control and security, might choose a custodial Lightning wallet. This is the least technically challenging option, but it undermines the trust model cryptocurrency and should therefore be considered only as a stepping stone towards more control and self-reliance. The more technical skills one has, the less there is a need to rely on third parties. So there are many ways wallets can be characterized or categorized. The most important questions to ask about a specific wallet are, does this Lightning wallet have a full Lightning node or does it use a third-party Lightning node? Does this Lightning wallet have a full Bitcoin node, or does it use a third-party Bitcoin node? Does this Lightning wallet store its own keys under user control, self-custody, or are the keys held by a third-party custodian? If a Lightning wallet uses a third-party Lightning node, it is this third-party Lightning node that decides how to communicate with Bitcoin. Hence, using a third-party Lightning node implies you're also using a third-party Bitcoin node. Only when the Lightning node has its own Lightning node does the choice between full Bitcoin node and third-party Bitcoin node exist. At the highest level of abstraction, the first question and the third question are the most elementary ones. From those two questions, we can derive several different categories shown on this quadrant on this slide. Remember, this is just one way of categorizing Lightning wallets. On the left-hand side, we got full Lightning nodes. On the right-hand side, we've got third-party Lightning nodes. And for our two rows, we got self-custody versus custodial. So in quadrant one, we've got high tech, where we got self-custody and a full Lightning node. We got high technical skill, least trust in third parties, most permissionless. In quadrant four, with custodial and third-party Lightning node, we've got low technical skills, high trust in third parties, least permissionless. And then we've got quadrant two for self-custody funds, but a third-party Lightning node, somewhere in between. The same thing for quadrant three, where you've got custodial funds, but you've got a full Lightning node. Quadrant three is not common, but there may be, some increase in the future. Lightning wallets can be installed on a variety of devices, including laptops, servers, cell phones, and so on. To run a full Lightning node, you're going to need to use a server or a desktop computer because they'd need to have a full Bitcoin node to go along with it. And mobile devices and laptops are currently not powerful enough in terms of capacity, processing, battery life, connectivity. The category for third-party Lightning nodes could again be subdivided. So we got lightweight nodes, which means the wallet does not operate a Lightning node and therefore needs to obtain information about the Lightning network over the internet from someone else's Lightning node. None, it means that not only is the Lightning node operated by a third party, but most of the wallet is operated by a third party in the cloud as well. So that's a custodial wallet where someone else controls custody of the funds. Some other terms that could use explanation include neutrino. This is a wallet that does not operate a Bitcoin node. Instead, a Bitcoin node operated by someone else is accessed through the neutrino protocol. Electrum, that's a wallet that doesn't operate a Bitcoin node. Instead, a Bitcoin node operated by someone else is accessed through the Electrum protocol. Bitcoin Core, that's your basic implementation of a Bitcoin node. BTCD is another implementation of a Bitcoin node. And here we got a diagram of a table showing examples of popular Lightning wallets and wallet applications for different types of devices. This list is sorted first by the device type and then alphabetically. So over here under application, we've got various names of wallets like Blue Wallet and Clear Mobile and so on. Then we got the device that's supported, smartphone, or which we're calling mobile, or desktop or server. Then we have the different types of Lightning nodes associated, whether they have none or full node or lightweight. Then we got the types of Bitcoin nodes that are associated with it, Bitcoin Core, BTCD, Neutrino, Electrum, and so on. And then finally, we talk about how are the keys being stored. Self-custody means you have control of the keys. Custodial means a third party has control of the keys. So the Bitcoin system offers an alternative blockchain for testing purposes, which is called testnet. And it's always recommended whenever you build your own software application to interact with Bitcoin platform, the first thing you do is you test it on a test net before you bring it live, because obviously if a live system, there's a risk of losing money. On testnet, the Bitcoin is referred to test BTC or TBTC, which is a valueless copy of Bitcoin used exclusively for testing, and you can get people to give you some if you ask nicely. Some Lightning wallets also operate on testnet, allowing you to make Lightning payments with testnet Bitcoin without risking real funds. You can get some TBDC to play from a testnet Bitcoin faucet, which is a software application on the internet, which if you make a request, it'll send you some testnet Bitcoin to your Bitcoin address. And so using testnet Bitcoin is a great way to experiment with Lightning without risking any funds. So for example, Clear Mobile, which I'm going to use as for some examples in this chapter, supports testnet Bitcoin, and so you can test it. Here's a few examples of testnet faucets on the internet, but there's many others besides those. And generally, you fill out a web form, and then they send you some testnet Bitcoins to your address. Lightning wallets have to strike a careful balance between complexity and user control. Those wallets that give the user the most control over their funds, the highest degree of privacy, and the greatest independence from third-party services are necessarily going to be more technically complex and difficult to operate. As the technology improves, some of these trade-offs will become less of an issue, and users may be able to get more control without adding more complexity. However, for now, different companies and projects are exploring different positions along this control and complexity spectrum, hoping to find the best spot for the users they are targeting. When selecting a wallet, keep in mind that even if you don't see these trade-offs, they still exist. For example, many wallets will attempt to remove the burden of channel management from their users. To do so, they introduce central hub nodes that all their wallets connect to automatically. When this While this trade-off simplifies the user interface and the user experience, it introduces a single point of failure as these hub nodes become indispensable for the wallet's operation. Furthermore, relying on a hub like that can reduce user privacy since the hub knows the sender and potentially also recipient of each payment made by the user's wallet. Um, so let's continue on and let's talk a little bit about how we would download and install what Lightning Wallet. So the first thing is always exercise great care when installing software on any device. There are many hackers out there who are posting fake software in an attempt to get users to download the software and then make it possible to steal money. So for example, if you want to install the Clear Wallet, what you might do is you might go, if you're using an Android device, you might go to the Google Play Store to download and install the wallet. And make sure you're downloading the correct app for the wallet you're downloading. Look at the number of users, look at the ratings. If you see an app with only one download or one user, that tells you that's probably a hacker version. Now, when you first install a wallet for the very first time, you might see things like options to create a new wallet, import a new existing wallet, and so on. So generally, if you're dealing with a non-custodial wallet and the user has sole custody of the keys, you can import the wallet using what's known as a mnemonic phrase. Um, Now, this means that Ellis is responsible for protecting and backing up those keys. If Ellis loses the keys, no one can help her recover her Bitcoins because the Bitcoins are associated with the keys. Now, so for most Bitcoin wallets, the mnemonic phrase is somewhere between 12 and 24 English words, selected randomly by the software and uses the basis to back up the keys. And you can use your mnemonic phrase to restore all the transactions and funds that are associated with that key, that's private key set in the case of a lost mobile device or a software bug or memory corruption. And if you're not importing and you're creating it for the very first time, then you're recommended that you write down that phrase on a piece of paper, not store it in your computer, because obviously if you store it in your computer, then you're exposing it to a hacker. Um, so for example, when installing a wallet, you might see a screen that looks like the screen on the right side. where gives you the phrase, the words like transfer, dirt, palm, file, pluck, lady, and so on. And so I recommend you write those words down. Also, write them down in order. And I usually put like a 1 in front of transfer, a 2 in front of dirt, a 3 in front of palm, 4 in front of file. Put the number of the order of the word in front of each word, just to make it explicitly clear to yourself the order the words came in. Because if you get the word sequence out of order, you will create a different key and your funds will not be there, and you'll be very unhappy. And it's important to store the mnemonic phrase safely in a way that prevents theft, but also avoids accidental loss. I myself have almost accidentally thrown away one of these mnemonic phrases, and I have a friend I know who has thrown some away as well. The recommended way to properly balance these risks is to write 2 copies of mnemonic phrase on paper with each of the words numbered. And once you've recorded it, then you'll keep it safe in different places. Now, I don't recommend you come up with a do-it-yourself security scheme. Instead, follow the best practices. Don't cut your mnemonic in half. Don't make screenshots. Don't store it in a cloud or encrypt it or try any other non-standard method. You increase the odds of losing your funds if you follow a non-standard approach to security. Instead, follow best practices because the best practices are designed by the experts to maximize your security. All right. So once your wallet's initialized, initially you won't have any funds until you put some funds in there. Um, so there's several ways you can acquire some Bitcoin. If you already have Bitcoin, you could put it in this wallet. If you don't have Bitcoin, you could exchange some dollars for Bitcoin on a cryptocurrency exchange. You could buy some from a friend or an acquaintance in exchange for cash. You can go to a Bitcoin ATM, which acts as a vending machine, selling Bitcoin for cash. I see a lot of Bitcoin ATMs in gas stations. I've seen them all over. I've even seen them in veterinarian offices. You can offer your skills or a product you sell and accept payments in Bitcoins. And you can ask, your employer or clients to pay you in Bitcoin. Here's an example of a Bitcoin ATM. In this diagram, we've got someone who's going to receive some Bitcoin in a Lightning wallet. They use a Bitcoin address from the Lightning wallet, show it to the ATM, and then the ATM then sends the Bitcoins to that Bitcoin address. Now, typically, if you're going to use do this transaction, receive Bitcoins from someone, you have to give them your address. Now, the address is typically this long string of characters and numbers at the bottom of this diagram here. We say 3JFZG574, etc. But that's really long and hard to type in. So rather than trying to type all that in, it's probably a lot easier to use a quick reference code. So we see a QR code up above it. And when you scan in that QR code, you'll get the address and then you can send Bitcoin. Now, for this particular lecture, I've actually grayed out the QR code, part of the QR code and part of the address, because I don't want anyone sending Bitcoins to that address because no one's checking that address. And if someone attempts to type in an invalid address, it should be rejected by your wallet. So the Bitcoin ATM is going to scan this QR code, and then it'll send, assuming you submitted some cash, you'll then receive your Bitcoins in your wallet. Now, if we look in our wallet, we can even see the transaction where the Bitcoins came in the transaction history tab of the wallet. Now, although the wallet should be able to detect the Bitcoin transaction in just a few seconds, that's the Bitcoin transaction being published to the network. It'll actually be about an hour before the Bitcoin transaction will be fully confirmed, because we usually consider a Bitcoin transaction being fully confirmed after 6 blocks. And every new block takes about an average of 10 minutes. Now, there are other ways to load Bitcoin into the the Lightning wallet. The same basic concepts would apply even if you use one of the other approaches besides using an ATM. Similarly, if you build a client for a service offered on the internet, you could send an email or an instant message with the Bitcoin address or the QR code. You could even print the QR code and display it publicly. And if you bought Bitcoin from a cryptocurrency exchange, you could withdraw the Bitcoin by pasting your Bitcoin address into the exchange website. The exchange then sends the Bitcoin to your address directly. Your Bitcoin is now controlled by your wallet and has been recorded in the Bitcoin blockchain. At this point, your Bitcoin is on chain, meaning the transaction has been broadcast to the entire Bitcoin network, verified by the Bitcoin nodes, and mined or recorded onto the Bitcoin blockchain. And so far, all we've done is we've used Bitcoin. We haven't used Lightning yet. Um, Now, as the case with many Lightning wallets, the clear example we're using in this lecture uses both Bitcoin and the Lightning Network because it's both a Bitcoin wallet and a Lightning wallet. So now we're ready to start using the Lightning Network by taking our Bitcoin off chain to take advantage of the fast, cheap, and private payments that the Lightning Network offers. So the first thing to do is to use Lightning channels. And the wallet actually provides a ability, a section within it to support that supports Lightning channels, where you can manage the channels that will connect the wallet to the Lightning network. So let's talk about what the definition of a Lightning channel is to make things a little clearer. First, the word channel is a metaphor for a financial relationship between your Lightning wallet and another Lightning wallet. So we call it a channel because it's a means for the wallet and the other wallet to exchange payments with each other on the Lightning Network off chain without committing transactions to the Bitcoin blockchain, which is on chain. The wallet that the first user opens a channel to is called her channel peer. Once opened, a channel can then be used to send many payments back and forth between the first user's wallet and the channel pair. Furthermore, Alice's channel, if Alice is our first user, can forward payments via other channels further into the Lightning Network. This way, Alice can route a payment to any wallet, for example, Bob's Lightning wallet, as long as Alice's wallet can find a viable path made by hopping from channel to channel all the way to Bob's wallet. Not all channel peers are good peers for routing payments. Well-connected peers will be able to route payments over shorter paths to the destination, increasing the chance of success. Channel peers with ample funds will be able to route larger payments. In other words, Alice needs one or more channels that connect to one or more other nodes of the Lightning Network. She doesn't need a channel to connect her wallet directly to Bob's Cafe in order to send Bob a payment, although she can choose to open a direct channel too. Any node in the Lightning Network can be used for Alice's first channel. The more well-connected a node is, the more people Alice can reach. In this example, since we want to also demonstrate payment routing, we won't have Alice open a channel directly to Bob's wallet. Instead, we'll have Alice open a channel to a well-connected node and use that node to forward her payment, routing it through other nodes as necessary to reach Bob. So at first, there are no open channels that we see in the Lightning Channels tab. The Lightning Channels tab displays an empty list. If you notice in the bottom right corner, there is a plus symbol which is a button to open a new channel. So Alice presses her plus symbol and is presented with 4 possible ways to open a channel. Paste a node URI, a universal resource identifier, scan a node URI, a random node, or an async node. So a node URI is a universal resource identifier that identifies a specific Lightning node. Alice can either paste a URI from her clipboard or scan a QR code containing that information. An example of a node URI can be shown as this QR code over here on the right-hand side. And down below it, we have the actual long string for that particular node. While Alice could select a specific Lightning node or use the random node option to have the wallet select a node at random, in this particular example, we're going to select the async node option to connect to one of async's well-connected Lightning nodes. Choosing the async node will slightly reduce Alice's privacy because it will give async the ability to see all of Alice's transactions. It will also create a single point of failure since Alice will only have one channel, and if the async node is not available, Alice will not be able to make payments. To keep things simple at first, though, we're going to accept these trade-offs. In subsequent lectures, we'll talk about how to gain more independence and make fewer trade-offs. So she selects the async node, is ready to open her first channel in the Lightning Network. When Ellis selects a node to open a new channel, she's asked to select how much Bitcoin she wants to allocate to this channel. In subsequent lectures, we're going to talk about the implications of these choices, but for now, she's going to allocate almost all of her funds to the channel. Since she'll have to pay transaction fees to open the channel, she'll select an amount slightly less than her total balance so we can cover the transaction fees. So in this particular case, Alice has 0.2 Bitcoin, 0.02 Bitcoin, and she's going to allocate 0.018 Bitcoins to her channel and accept the default fee rate. And we can see this over on the right-hand side where we're allocating 0.018 Bitcoins to open a new channel. We got the node ID as for our node or our async node, the port number. There's going to be a transaction fees, 20 Satoshis a byte, and that's a fast priority. And then this on-chain funding transaction is sent to the Bitcoin network for confirmation. Alice now has to wait for the transaction to be recorded in the Bitcoin blockchain. As with the initial Bitcoin transaction she used to acquire Bitcoin, she has to wait for 6 or more confirmations, which will take approximately an hour. And then we should see the confirmation over there on the right side. In this particular case, at 0.0818 Bitcoins is worth approximately $166. And it, for the transaction fee, 16 of which was for the transaction fee, and 150 is going to be what you'll have available for funding. Once the funding transaction is confirmed, the channel to the async is open, funded, ready. The channel amount still contains 0.018 Bitcoins, but in the time between the screenshots, the exchange rate has changed. The US dollar rate is a little bit different. It's now down at 149.91. You can choose to show balances in Bitcoin or dollars, but keep in mind that how the dollar values are calculated will change over time. So now let's buy a cup of coffee using the Lightning Network. Alice now has everything ready to start using the Lightning Network. As you can see, it took a bit of work and a bit of time waiting for confirmations. However, now subsequent actions are fast and easy. The Lightning Network enables payments without having to wait for confirmations, so funds will get settled in seconds. So Alice has her mobile device and she's at Bob's Cafe in the neighborhood. She wants to use her new Lightning wallet to buy something. Bob has a simple point of sale application for the use of any customer who wants to pay with Bitcoin over the Lightning Network. As we've seen as we're going to see in the next lecture, Bob uses a popular open source platform, BTC Pay Server, which contains all the necessary components for an e-commerce or retail solution. It includes a Bitcoin node using Bitcoin Core software, a Lightning node using the C Lightning software, and a simple point of sale application for a tablet. BTC Pay Server makes it simple to install all the necessary software, upload products and pictures, and launch a store quickly. On the counter at Bob's Cafe, there is a tablet showing you what we see here on this point of sale application picture. You get a black coffee for $2.50, a latte for $3.50, a cappuccino for $3.50, and then you can also pay a custom amount. So Alice selects the cafe latte option and is presented with a Lightning invoice, also known as a payment request. So we got the QR code, we've got the amount of Bitcoins that the particular products cost, and then you need to open this in your wallet. So to pay the invoice, Alice opens her wallet and selects the send button. under the transaction history tab. And then she's going to go ahead and select the option to scan a payment request. So she'll scan the QR code from the tablet, point of sale tablet, and then she's prompted to confirm her payment. She'll press pay, and a second later, Bob's tablet will show a successful payment. Alice has completed her first Lightning Network payment. It was fast, inexpensive, and easy. Now she can enjoy her latte, which was purchased using Bitcoin through a payment system that's fast, cheap, and decentralized. But from now on, Alice can simply select an item on Bob's tablet screen, scan the QR code with her cell phone, click pay, and be served a coffee, all within seconds and all without an on-chain blockchain transaction. Lightning payments are good for Bob too as a seller. He's confident that he's going to be paid for Alice's latte without waiting for an on-chain confirmation in Bitcoin. In the future, whenever Alice feels like drinking a coffee at Bob's Cafe, she can choose to pay with Bitcoin on the Bitcoin network or the Lightning network. Which one do you think she'll choose? So in summary, in this chapter, we took a look at Alice as she downloaded and installed her first Lightning wallet, acquired and transferred some Bitcoin, and then opened her first Lightning channel and bought a cup of coffee by making a first payment on the Lightning Network. In the following lectures, we're going to look under the covers at how each component in the Lightning Network works and how Alice's payment reaches Bob's Cafe. So a Lightning Network node is a software application that has three important characteristics. Lightning nodes are wallets. They send and receive payments over the Lightning Network as well as on the Bitcoin network. Nodes must communicate on a peer-to-peer basis with other Lightning nodes creating the network. Lightning nodes also need access to Bitcoin blockchain or other blockchains for other cryptocurrencies to secure the funds used for payments. Lightning node network explorers are useful tools to show the statistics of nodes, channels, and network capacity. Wallets have varying components with varying degrees of reliance on third-party providers. Key store is an important component with respect to reliance on third-party providers, as the control of the keys determines the ownership of the cryptocurrency. There is a trade-off between complexity and control when choosing different implementations of wallets, and we walked through the process of setting up an example Lightning Network wallet. We'll also walk through the scenario of a transaction over the Lightning Network. Lightning Network is fast. There's no need to wait for Bitcoin block confirmations that would normally take an hour or so. Lightning Network is also cheap as it saves on the Bitcoin transaction fees, as off-chain transactions do not need to be recorded on the blockchain ledger. These slides are available under a Creative Commons Attribution Share Alike. And these materials are based on the Mastering the Lightning Network book by several excellent authors on Lightning. And these materials are not investment advice or legal advice. They're for educational purposes only, and mentions of particular blockchain projects should not be construed as an endorsement. Thank you for watching this lecture.